All right, so I've showed you how to determine if a function is one-to-one by looking at the graph. Now, what if I just give you the function? And I don't want you to graph it. I want you to be able to determine analytically if this is a one-to-one function. Remember, one-to-one means if I have equal y values, that means they came from the same x value. Okay? The way that we would write that before we answer this question, is this one-to-one? This is the analytical definition of one-to-one. It says this: if the function value at a is equal to the function value at b. Remember, this notation means I have the same y value. The y value at a is equal to the y value at whatever b is. Then what that means is that a has to equal b. Because if something's one-to-one, if the y values are the same, that means the x values had to be the same. Otherwise, if this was not true, you would have y values that were produced by different x values, like the parabola. That's not one-to-one. So hopefully you've written this down. Pause the video if you have not. We are going to use this definition of one-to-one in order to determine analytically if this right here is a one-to-one function. So here goes. Here is your first step when you go to perform these problems, and there will be one of these on the test. Here we go. I'm going to start with this statement. F of A equals F of B. Now what I'm going to do, I'm going to plug A into my function. So instead of having 3x minus 5, when I plug a in, I'm going to have 3a minus 5. And then I'm going to plug b into the function and have 3b minus 5. And now all you do with whatever function you're trying to test for is you solve for a or solve for b. It doesn't matter. So if I add 5 to both sides of this, I end up with 3a equals 3b. When I divide by 3, that means a is equal to b. So is this a one-to-one function, 3x minus 5? The answer to that is yes, it is. Here's another example. I'm going to change the function. So this time, I'm going to do this for the function g of x, x squared minus 5. Now, spoilers, we know x squared is a parabola. And I showed in the last video graphically that a parabola is not one-to-one. How do I know that from the algebra? Well, here we go. I'm going to start off with that first statement. G of A equals G of B. I'm starting with the same y value. And I want to know, do these y values have to be produced by the same x value? Or can they be produced by different x values? So when I plug A into the function, I have A squared minus 5. When I plug B into the function, I have b squared minus 5. I'm going to add 5 to both sides of this. And now in order to undo the squaring, we talked about this in our section on quadratic equations, I'm going to take the square root of both sides. And then here's the thing. When I take the square root, okay, if I'm going back up the ladder and I was to square both sides to get back up here, there are two things that I can square to get b squared. I can square a positive value and I can square a negative value. So what that means is when I started with the same y values, they did not have to come from the same x value. There is a positive value and a negative value. So that's why this is not one-to-one.